In this lesson we will learn how we can subtract two vectors. So the operation that we want to do is this: vector 1 minus vector 2. If you subtract two vectors, the result will be the vector between those two positions. So something like this. Where is it? Here. Yeah, so if you subtract vector 1 minus vector 2, this one minus this one, the resulting vector will look like this. The rule here is tip first, which means the tip of our resulting vector will point to the position of our first element. So vector 1 is our first element and vector 2 is our second element. So the tip of our resulting vector will point to our first element, vector 1. If you make it the other way around, so vector 2 minus vector 1, the resulting vector will look like this, just in the other direction. You should always keep in mind that the vector always has a direction and a length, but not really a position in space. So the resulting vector will actually not be here in space. It will be like this, but it gives us the direction and the length between our two vectors here. So what can we do with this? One example could be that we want to place a third object, for example, again our cone, always in the middle of those two objects, so somewhere here. This can be useful in a lot of cases, for example, for character rigs in the face, facial rigs, or if you rig something mechanic like a robot, or a lot of other cases. So what we want to do now is to calculate this position, which is always exactly in the middle of those two. To do this, we will do the following. Let's move it over here, maybe. So first, we subtract vector 1 minus vector 2, which will give us this vector here. Afterwards, we want to scale this vector down by half, so that it has only the half of its original length, so something like this. When we've done this, we want to move this vector at the tip of this vector. In the earlier lessons we learned that we can do this by adding those two vectors. So our resulting vector plus vector 2, the position vector of our cube. Then it will look like this. And this is how we will calculate the position, which is always exactly in the middle of those two. So then we can place our cone here. And if we now start to move our two objects, the cone will always be exactly in the middle. So let's jump into 3D. Let's put it back, that we can see what we do here. Okay, let's jump into Cinema. Again, we have our three objects. I double click the XPresso tag to open the editor. So first of all, we need to subtract the two objects. So I'll take my sphere and my cube, create an output port for the position, control double click on the title to resize them. And now we need a math node. Let's take the math, set the data type to vector, because as we see here in our information bar, if I hover over the output, we have two vectors. So the math node has to be on data type vector, and the function to subtract. So let's plug them in. So vector 1 minus vector 2 will give us the resulting vector. So what we've done now, if I jump back to our coordinate system, this vector minus this vector gives us this vector. So now we want to scale this vector down to the half of its length. To do this, we can use a new node, which is called float math. So connect our resulting vector to the input. And what we can do here is set the data type also to vector, of course, and the function maybe to multiply. And what we can do now is we can multiply our vector with a normal float number. So this second value is not a vector, it's just a normal number. And if we set it to multiply, we can scale our vector. So we can scale the length of the vector. So if I type in 0.5, it will reduce the length of our resulting vector to the half. So it will divide it by 2. We can also set the function to divide and type in 2. This will be the same, but I want something like a scaling vector. I like it more. So I set it to 0.5. Okay, what we've done now, if we jump back in our coordinate system, we now took this vector and scaled it down by half, so it should look like this. What we need to do now is take this vector and put it at the tip of our position vector of the cube, so vector 2. So in earlier lessons we learned how to do this, so let's jump back in 3D. And we need a new node. Math. Let's move it over there. Math, set the data type again to vector, function add, and we want our calculated new vector plus the position vector of our cube. And now we can take our cone, create an input port for the position, and connect it. If we now jump to the view and start to move our sphere around, we see that it works perfectly. The cone is always exactly in the middle of our two objects, no matter where I move them. And the cool thing now is that we have this float math node here with our float value. If we jump back to our 3D view, like this, and when I now change this float value to maybe 0.2, you see that it's now more on the left side, closer to the to our cube, because now the vector between those two is not multiplied by 0.5, which will be here, but by 0.2, which scales it more down like this. And you can change this to 0.1 or 0.6. So now you have a control where you can slide this third object, our cone, between those two, and it will always be exactly on the line between those two. Can be quite handy. So in this lesson we learned how we can subtract two vectors, how we can calculate new positions between those two, and how we can create something like a custom control with this float value to change the position between those the resulting position between those two objects. In the next lesson we will take a look at the matrix and learn what a matrix is and what we can do with it.